Who saw the demo this morning in the, what session was it? Like the welcome, the keynote?
Yeah.
Saw the .NET CLI demo. All right.
I think we have a mic on.
All right. Oh.
Test.
And who saw that and thought, that's odd. What does DNX mean with that demo as well? And what is, okay. Well, we're going to explain all of that now about what all those things mean. Because this on, like, it's weird. It doesn't sound like it's working as well as it did before.
Sounds like
it's all good. Okay, I will just chill out and relax. Someone reminded me that we didn't ask, how many people are actually using ASP.NET 5 now, like for real stuff? Wow, awesome. Thank you, team. That was well done. Who's using it on .NET Core? 1, 2.
Well done, sir.
You are brave, brave people. That's good. And who is using it, of those 2 people, who is using it on a platform other than Windows?
You're crazy.
2, 3. Oh, there was other people over here on blindsided apparently on this side.
On Mono or on?
On Mono or on .NET Core on that platform, on Linux?
Mono.
On Mono. How about .NET Core?
.NET Core, but the ecosystem is...
I know, but that's why I'm asking. Is anyone using .NET Core on Linux or Mac, like for real stuff? What is it? What do you do in your app, sir?
Hello world. I'm really the only one.
You're the only person. That's why I'm picking on you now.
Okay, so really it kind of became an internal CNC app for command and control for some of the operations that we have going on.
Nice.
Signar?
So it's very UI-driven, sort of?
It's very UI-driven.
Okay.
And that was the idea behind it, was to put an external-facing part of some of our operations to some of our internal and external operations people that aren't necessarily technically
Okay.
inclined to be able to do some of these things, but are able to respond to events that our
Okay.
customers are bringing up and things like
And does it talk to a database or to web services, HTTP, for its back-end data?
that.
Okay, that explains that. Okay, awesome. And have you been...
Can you summarize what other people are talking about?
He built an awesome app, so his customers can do awesome stuff. And the stuff, like, customers can look at data in his app. That's pretty much what he said, but like more domain specific. All right. And have you been keeping up with the betas? Like, when did you start? What version?
I started on 3.
Beta 3?
Yes.
Okay, and you're running on beta 8 now?
I'm on 7, and I'm frantically poking at 8 right now.
Great.
Nice.
So on 7, frantically poking at 8. Just to reiterate, RC1, RC1 will be out in November, okay, second half of November, and we're about to talk about stuff that will affect post RC1. Okay, so everything you're about to see, I know that's terrible, but I am going to make it worth your while. There will be changes post RC1 before we RTM, and we're about to go over the biggest one right now. But your actual application, if we do our jobs well, your actual application that's built on RC1 will not change drastically, if at all, on RC2 and subsequently RTM. Okay, so with that introduction, let's start talking. We have a guest from the .NET team here. This is Peter. I just say Peter, but it's probably Pietro or something.
Ooh.
No, I just totally destroyed that.
Butchered that. Damian.
Damian. Hey, I have alarm calls me all different types of pronunciations, don't worry.
I'm Piotr Pushkevich. I'm a development manager on the .NET team.
And we know Fowler.
Peter's fine.
Peter's fine.
Who are you, Andrew?
I'm Andrew Stanton Nurse, and I'm an engineer on the ASP.NET team.
Awesome.
Okay.
So I've set the scene. And so with that, I want to very quickly say that people thought that the experience we built for DNX was pretty cool, right? So we built this very command line, console-centric experience for .NET, essentially, because in part of taking ASP.NET cross-platform, we had to build a new foundation. And rightfully so, a lot of people said, well, that's interesting. You built this command line experience. What does that mean for the greater sort of .NET ecosystem? Is this going to be the command line experience for .NET on Linux? And we never really gave a concrete answer on that. And the reason was because we were working with the .NET team to build that very experience, but we couldn't slow down what we were doing. And so the very short way of saying this is that post RC1, DNX will cease to be an entity of its own. Okay, you will never see the letters DNX again after RC1. They will be replaced by this new experience that we're going to show you right now. And if you squint and look, you'll go, wow, I actually see a lot of what DNX did in this experience. And there's a reason for that. You know, a lot of the code has been copied over, Andrew's copied a lot of the code. David's copied a lot of the code. .NET team has copied a lot of the code. And then we've enhanced it. We've made it a little more generic so that some things that DNX did that were a little quirky and sort of not .NET-y have gone away. And hopefully we've kept the best stuff. We're trying to make sure that we keep all the really good stuff while making sure that we're building on a fantastic new foundation that will become the foundation for .NET cross-platform at the command line moving forward. And it looks like we already have a question. Sean?
I want to confirm, this is post-RC.
This is post RC1. So I will reiterate that again. RC1 will ship built on a thing called DNX. And that will be the last release of DNX. RC2 will ship early February. I just literally pulled that number out of my mouth. Ish. Hopefully.
It's like Ilan always said about MVC, like 1. It'll ship in a month ending in burr, like June burr.
That's right. And RC2 will be built on top of this platform. That is the intent. Okay? And then RTM obviously will be on top of this platform. RTM will be in March, April next year. We say Q1. We'll hit Q1. March-ish. And as a result, this experience obviously will have to ship in some supported version at that point as well, because we'll be shipping on top of that. Okay? So hopefully that sets the frame. Yes, we are sprinting from where we are right now to re-platform ourselves on top of this, but we're using all the good work that we did for DNX and a lot of the good work that the .NET team had done, some of it publicly and some of it not so publicly as well. So we're going to have a look at all that now. So that's the preamble. I will shut up now and let these guys do the actual work.
All right, I guess I'll show off. So yeah, you can see up on the slides there, but it's switching away. So there's a new command, .NET, and you'll get it through various means, probably apt-get and MSI, things like that. But at its core, it still runs the exact same kinds of projects that DNX ran. So here I've got a console application. It just writes out a message that comes from a library, and the library is just returning a static string. It's got a project JSON. It's referencing the library. It all looks like a DNX app. Nothing really different here, except a couple little things. It says up here, emit entry point true. That's because what we're going to be doing as part of running and compiling applications is we're going to be actually building exes, basically, in the traditional sort of .NET way. So it's going to have an entry point, and it means you're going to have a public static void main. So you've seen DNX apps have a public void main. We now have switched it back to public static void main. It gets us a lot of benefits. It brings us in sync with a lot of the rest of the .NET platform. But we're still going to be able to sort of preserve a lot of our sort of DNX magic in this. So simple app, looks like a DNX app. In fact, it still runs like a DNX app. And it takes a few seconds to do its dynamic compilation. Yeah.
And that's an important point, because that lends itself to what we said about hopefully your RC1 app will just work on top of this new thing. We've already got that working, essentially.
I mean, this is a console app, but it runs in DNX. But just as well, it runs in .NET, which is this new thing. Right now, it'll take a little longer because it takes a little longer to compile because it's all debug bits and things like that. But it's eventually going to spit out the same thing.
That's fast.
But something different happened here, something not quite the same as DNX. When I ran DNX run, we have Roslyn sitting inside the DNX process. We load up your code, we compile it in memory, we immediately launch the compiled binaries, and then when DNX shuts down, compiled binary's gone. .NET run and the .NET command works a little differently, a little closer actually to the traditional model. So what .NET run actually did behind the scenes is it ran this command, .NET compile, which is a lot like the NU build. It's going to do a compilation. It would tell me if there's any errors. You'll see it still says DNX core in there because we're still reusing the old TFMs in a lot of this prototype stuff. That'll probably get changed to one of those DOTNET TFMs later, framework names. Yeah. So I performed a compilation here, and I've got a bin folder, just as you'd kind of expect. And if I go into that, you'll see some things. We did, just like with DNX, we built your project, and we built all the projects that are referenced by that your project references, and we copied those locally. But you'll notice you don't see in here things like system dot whatever. We didn't copy everything into one giant folder, so we still have a pretty slim folder. But you'll see we've got a managed DLL here. It's called a DLL, but it's really an exe, and it's what we compiled that code to. But we've then taken a little bit of extra code that we have inside the .NET runner and basically copied it into your app. And this is a native executable that will launch the CLR and then load your application and run it.
Hang on, isn't that what DNX was before?
Exactly. So effectively what we've done is we've copied DNX into your project.
Who was annoyed that you couldn't produce an exe with DNX that was named after your app?
Or that you
couldn't
attached
tell.
the process
You couldn't
and
tell
you
it
saw
was running.
50 DNX.exes and you didn't know which one it
that
was.
annoyed me. I admit that one did annoy me.
So like I can actually look, and this is just a little tool on Unix machines. I can just take a look and test app. So that's Mach-O, that's a Mac native binary. And then this is your managed binary, that's PE executable for Windows, whatever. But now that it's compiled and it's sitting on disk, I can just run it, and again, and again, and again, and again, and again, and it doesn't take, it's much faster. It's already compiled and ready to go there. And this app you can then run on your machine. You can use it in a good development cycle. We can still have things like our DNX Watch, except it won't be called DNX Watch. I guess it'll be called .NET Watch.
Probably.
That will recompile. So you still get a lot of the kind of flow of edit and run and so on. Yeah, you got a
Is
question?
there a cross-compile story?
Yes.
The question was, is there a cross-compiler story?
Yeah. So I don't have a project set up for it, but if you actually look at help for compile, you can do things like, say, framework. When you want, so the outputs of this compile are, if we look at this guy, this managed DLL is portable, right? It's managed code. It can run anywhere as long as you've got all of the CLR bits and things like that. This application is native and specific to Mac OS. I think just x64 right now. It could be fat binary on Mac OS. If you want to take this application and move it to another machine, generally, we're kind of going to probably lean towards using the publish command, which is a lot like DNU publish was before. It will take your application, it will bundle it up with all of the runtime assets you use and everything. And I think we're still working through it. There'll be different levels of this. There might be levels where it will bundle up the things like the packages you used, but it'll keep the CLR separate, and you can deploy the CLR to your machine as a global sort of server installed thing and figure that out.
Actually, it's very similar to what DNU is now. In fact, it's probably fair to say that if you think of the DNX app today, DNX.exe, and you think of the DNU command, and you squint and you merge them together, and NuGet.exe to an extent, that ends up giving you .NET. So it's one command that can be used to drive lots of commands underneath the covers that lets you, create an app, restore packages for an app, install packages for an app, compile your app, run your app, package up your app so you can run it, test your app, package your class library as a NuGet package. It is the one-stop shop as a console library or command library experience for .NET application development. And ASP.NET 5 will be built on top of this one-stop shop. That is effectively what DNX and DNU were before. This is now a unified experience that works pretty much for everything. Question.
So for the scenario where we're sitting there in Visual Studio doing our development work, are we going to be writing those DLLs and executables to disk every time that we hit Control-S?
So the question was, if I'm in VS and I'm doing coding, does that mean every time I save my CS file now, it's writing stuff out to disk, whereas previously it wasn't with DTH?
Yes.
The answer is most likely yes. We still intend to keep the experience in Visual Studio, whereby you don't have to compile your ASP.NET 5 application when you make a change and then go back to the browser and hit F5. We'll just do a background compilation for you now, and we'll do all the work to make that as fast as it has to be.
Do a run and show the actual verbose output.
Yeah, so I can actually show the verbose output here. We've got a command to do that, and I'll actually clear up some things just to make sure we're extra clean there. So .NET itself, the .NET executable, is actually extremely simple. I can even show the code. It's super simple. It does nothing except basically take the command you gave it, stick a dash in between the two words, and run it, which is a lot like how Git works. And I think Peter's going to talk a little bit more about that, about how you can use that to plug in other tools. So what I did is I just got a little trace here that's showing what running .NET Run did. And it ended up running .NET Compile. It's outputting to a temporary directory. And that's running compile on your dependent projects. It gets a little hard to trace here, but here we're compiling the test library. And then we compile the actual sort of your project library, we're calling out to csc.exe. So we're just running the standard Roslyn-based compiler. And then finally at the end, it just took the output. And the output is just exactly what I showed in that previous example. It's that bin folder with a couple files in it. And it's just running that output and showing it, and then cleaning it away. Right now it cleans it away. There'll be options to sort of preserve it.
And that's because you explicitly called run.
Because I called
as opposed
run.
to compile.
Yes, so when I call compile, it's producing a binary that I'm going to keep reusing and reusing. When I call run, it's producing that binary as a temporary artifact and then throwing it away.
Right at the back.
Yeah.
I got two questions. First one is that can we create custom commands on top of this? So like you said,
Yeah.
dotnet compile blank. So like for example, DNX, we have EAP, we have web, other ones. And has that story been developed yet?
Commands are still tricky. We're trying to figure that out right now. But you can build tools on top of it.
Yeah.
That plug into this actual tool. So you can build .NET dash blah, and then run .NET blah, and that will run.
So for example, when Glenn showed DNX Watch and something like user secrets today, we will rebuild those tools on top of this experience. All the code will practically stay the same.
Same code, yeah.
But we will now output a NuGet package that contains those tools, and you'll be able to install them either via NuGet or via this experience. So you'll still be able to do the global commands experience. In application commands, where you can have your project JSON and have a web command and a Kestrel command, and they call different entry points, that's the one that's still
TBD.
to be determined.
I think there are some aspects of that, like it's used a lot in our code for unit testing.
Right.
We say this project has one command, it's called test, and it runs the XUnit runner. Scenarios like that where we want to use, my code is not actually the entry point. There's sort of a separate piece of code that is the entry point that then calls into my code. That scenario is still
Yes,
something
still
I think we
important, yeah.
want.
EF will use that scenario,
It's just
for
things
example.
like, well, and it's things like having an EF command inside my application doesn't actually make as much sense as having an EF command that I can run inside my application
Right,
and sort of do it. So having to have that sort of embedded in my application was a bit odd.
The reason why I was asking is that was a nice thing about DNX.
Yep.
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 Command and we use it everywhere.
Yes.
So the
Yes,
biggest-
it was nice, and you will still be able to do that.
yes, yeah, I think you'll still be able to do that. It may not be something you put in the project. It may be a global command, and we're providing, like, this tool is using a library we're writing that is basically DNX in library form. And so that would allow a global command to basically go and say, take a look at this folder, load up a project context, and now I've got all the information I need to run commands in there to say, make a EF migration or do things
Right.
like that. Yeah.
Was there a second part of the question?
The second question altogether is that I know a couple years ago when we went through and we showed K in the exact same room,
Yep.
all about, hey, look how fast this is and all the memory.
Oh, you remember? Oh,
Dang it!
We hoped you wouldn't remember and ask this question. Yes.
Yep.
How do we go, what was it?
Just trust us,
So-
and that will make it fast.
It's going to be super fast. Even faster, maybe. Who knows?
K was like, this is
Yeah.
slow, don't ever use this.
That's true, but
Yeah.
not everyone had an SSD back then. And if you don't have one, then shame on you, because they're like $80 on Newegg for a 256 gig name brand SSD.
To be fair, it is faster sometimes.
But not always.
It doesn't scale to 100 projects, for example. So if you build MVC and you do the next test, it recompiles
Everything.
which isn't scale, right? So it works up until a point, like maybe 10 projects is faster if you did change it every time. But if you didn't, then you kind of pay the cost of compiling your entire PDP graph all the time.
And
Yeah.
the other way of saying this is that the Roslyn compiler team recognized this issue of paying the cost of things as you compile them over and over, and they solved it with the second process, the compiler server process that we actually use in the web forms and MVC5 templates to solve this problem. So we want to kind of leverage the solutions that already exist in the core .NET tools. And you should end up with the same experience, if not a better experience than what you had before. If you open the MVC source code today and try and work with it in Visual Studio, just ask the MVC team. You get to a point where doing certain things is just not as great as we want it to be.
They love it. Right, Ryan?
And so we want to make that experience great, and there are solutions for those things already, and this is part of doing that. But good
Yeah.
question.
And I mean, there is real sort of performance value in the fact that I don't have to recompile when I'm just rerunning the same code that I've already compiled
Right.
once.
Sean, did you have a question?
Very brief. I want to be clear about this. This is NDA until RC1?
This is NDA
Until
until RC1 is announced in public. Is that, I think that's fair? Someone told me in the room that if it's wrong. Okay, Richard, that's fair. Yep. So this is NDA until then. There is a repo that has this stuff in it, but it's private right now. It's why you can't see it. Sorry?
When is this not NDA? The video recording.
This entire session is NDA until we
November?
release RC1. I don't think we've shared the RC1 release date in this room, have we? I mean, we can.
Do it in this NDA session.
November 18.
Okay. So
Day before my birthday.
I told you earlier today you could probably figure that out if you went and read all the tweets from the Microsoft developer account, right?
they sent the same pages of the keynote.
Oh yeah, I was totally watching
okay.
that. Yeah, you all knew that. Sorry. Yeah. Good.
Yeah,
All right.
I think that's most of what I had for demoing stuff.
All right.
Cool. So I want to show you guys something that kind of brand new, and you saw part of this in the keynote today. Kind of blew up, which is a
You're good.
oh, thanks. Which is a good indication of just how hot off the presses this stuff is.
you're
But
You've extended.
Yeah.
You've extended your screen. Okay, good.
we're okay. So the thing that I want to show you guys is the .native flag that we can pass into .NET compile. I'm going to use a much simpler application than we tried this morning.
Wonder why.
I'm just kidding. And let's see if this is actually big enough.
I can't even read that, and I'm standing here. So.
How do we make putty bigger?
Maybe just try Control Plus.
Control plus.
try it.
Definitely won't work.
Nope.
Of course not. It's putty.
Hot off the presses.
Go.
Settings.
Yeah, change things.
Aha, it's on my.
Either what? When?
I think someone blogged about that, didn't they?
Windows Plus.
You could just,
Yeah, you could just
Alpha.
use magnifier.
No
could
thanks.
just use the magnifier.
But this is it looks like
There
we
go.
got it.
We
Looks
got
like
it.
we got it.
It's all come.
Hit apply.
Yep.
There we
How's
go.
that?
Hey, big.
Okay. So I have a very simple application. It does exactly what you'd expect it to do. Hello world.
It has tabs though. Oh my gosh.
Or maybe just multiple spaces, David.
That's tabs. That's definitely tabs. I can see
Fowler
it.
has
It's
tap
just-
sense. Yeah.
You can read Unicode characters off the screen.
burning
I
my
love
eyes.
it. I love it.
You should have changed the bracing style just to really mess with it.
Yeah.
Oh my god.
So I'm going to go ahead and .NET compile this guy, which will do exactly what you saw before. We're now compiling to IL. We'll get a native host that can then launch the IL executable application. But boy, it would be kind of neat if I could get that startup time a little bit faster.
12 seconds.
Not just a compilation. So what the team has been working on is actually bringing the .NET native experience to the command line to be able to actually execute arbitrary console applications compiled to native. What I can do on top of this compilation is basically rerun it with the native flag. And what's going to happen is we're going to generate that same IL, and then we're going to take the IL and use it to produce a completely standalone native version of the exact same application. And so you're seeing that happen live right now. There's obviously opportunity to tweak performance, but
This is fine.
I
You have to
think
pay a cost when
Get
you go
coffee.
native, right? I mean, this is fine. So good.
so.
Did
Let's
the
see-
native
let's see what
compilation
we have.
finish faster than the C#?
I think
I think
so.
it's
compilation did?
Where is the C# team? C#
Well,
team.
so there's a lot of the C# code is compiler is still being jitted and all
That's
that.
right.
You know, we got
So,
native compile.
so in my compile output, I now have a new directory called native. I'm going to go and switch into that guy. And there's a single file, which is actually kind of nice. All of my dependencies, everything that I need to run this application has been compiled into a single binary. So it's completely standalone. I'm going to go ahead and
Every dependency.
That is completely
All
standalone.
dependency.
Everything.
System dot
For
everything.
this
CLI.
platform.
everything.
Well,
For this platform.
yeah.
Right.
What is it running on? Windows?
This is on.
This is Linux.
Linux.
This is Ubuntu 14.4. You can see here that this actually is a native executable, so
Yeah.
it's no longer IL. And if I run this guy,
Dot slash.
That's slash.
Fast.
That was fast.
I don't think I can actually hit the buttons fast enough to make it slow down.
That is just
There you
crazy
go.
fast.
What is the size of the binary?
Yeah.
Yeah,
Very good question.
question.
What's the size of the binary? These are the right questions to ask because it's like, why would I go native? Why do I care? Let's
Any-
have a look.
Any
It's
guesses?
native.
Oh yeah.
How big do they think Hello World's going to be?
Price is right.
Huh?
Price is right. Who? 15, 8.
2 megs, 15 megs,
Okay.
under a meg, all right. 500K,
Put dash H in the end.
just under 2 meg. Maybe?
Under 2 megs,
1.8 meg.
1.8
2
megs.
meg, there you go.
Now, don't get accustomed to that size. There's still a lot more left to put back into the native compiled world.
Don't worry about it. We could make it bigger. It'll be fine.
But if I'm writing one of those text-based RPGs, then I can have a file that's 2 megabyte text-based RPG, right?
Very, very small.
700K smaller than the Go binary.
700K
Yeah.
smaller than the Go binary.
Yeah.
It's almost like we planned that.
Oh,
No, we didn't. But
Yeah, so part of what you saw with the larger application blowing up during native compilation just shows that there's a lot of capabilities of the runtime that aren't yet baked into the native experience. And so as we light up more features, that's going to take more code and it's going to grow the binary. But we're absolutely focusing on keeping that size reasonable and competitive.
cool.
Competitive. Nice word.
Is this cool? Like, do people understand why this is interesting?
It's okay to say no. Yeah, awesome.
So to put this in perspective of the timelines we've already shared, and obviously this is just a console app, like there's no web or anything in here, we're in the ASP.NET talk. We totally want this to work for ASP.NET. I think Fowler even
Is he
might
gonna
have pulled
try?
something out of his
He's
back
gonna
pocket
try.
Done with
to
this crap.
see what happens when we do this on an ASP.NET 5 Hello World applications. So not only can we potentially take ASP.NET 5 cross-platform, which obviously we all know the benefits of, what if we could take it cross-platform and native? What type of benefits do you get there? And what do you lose potentially? Because there's always trade-offs, and we can talk about some of those in the timelines as we keep going. Yes?
Can you run the native app on a different machine without running any .NET?
So the question was, can I run the native app on a different machine without having like a .NET SDK
You mean, is it
or
native?
runtime? So it's compiled native for the platform that you ran it on. So I could pick that up and put it on another Ubuntu machine in this case, and it would run. But if I wanted to run it on Windows,
you'd have to cross-compile.
I'd have to cross-compile, and
Which
that's
is
two
something
native. That's what native means, right? You have to be able to run it on both of those platforms.
But the
with a native
binary
image.
itself only depends on the OS at that point.
Right.
Yes.
Pretty much.
So the shared runtime experience is the IL experience. Okay, so if you want to have like Azure website or your own web server where you have all the runtime installed and your packages and not have to pay the cost of deploying those, the IL experience with the shared runtime gives you that experience. Okay, you get that benefit. If you want the benefits of startup time and low working set and all the other stuff native potentially gives you, then you have to compile everything in and take it with you. So
So I have this super hacky demo.
Yeah, you just told me
That-
it still works.
It still
I
works.
think it still works.
I think it still works.
Where I had to kind of gut ASP.NET a little bit because it is so new still, making stuff work on native. So this is kind of an ASP.NET app running on a libUV server. So libUV, UV loop, that kind of stuff.
no, a libUV server.
It's not
A
Haskell.
libUV server, yeah. It's a super minimized, hacky one that just p-involves into stuff.
But this bit looks the same.
So this is your configure application. You call app.run, hello world, but this is C++. So I think we spoke about the different kinds of ways we go to native. One is reuse it from IL to reuse it to an object file to native, and one is from IL to C++ to native. And this is kind of the second one. And the compiler actually generates some gnarly code where it takes all the IL and generates this magic.
You had system string in
It's
there.
great, right? So it
Jar.
literally recreates the entire .NET framework
In one
in
file.
a single file.
Single file.
It's the best thing ever.
It's not the entire .NET framework.
Of course
I mean,
not.
It's,
The-
it's
the
a-
GC
It's the thing you use,
Yeah,
yeah.
exactly.
The GC is linked in and the runtime is linked in, but you can, if you say it sounds better. So
Yeah,
this is the
yeah.
entire
Sorry, I'm
framework
sorry.
in a single file.
How many lines go to the
27,000 line
bottom?
file.
This is line.
Oh, more.
Oh wow.
34,000 lines.
Yeah.
This is how productive .NET has been making you, right? Like that one file.
Yeah, you could have written this yourself.
35,000 lines of C++.
Yeah, like void star 8 10 anyway.
Anyway, let's run
So I'll hit F5. Cross the fingers. They didn't break it. Overnight. Bit rot,
it. Bit right.
maybe.
It's still going.
Come on, VS. All right, and and some magic in the debugger lets me actually step through the managed code, even though this is C++. So if you look here closely,
Zoom in.
this is like
That's a
RV.
native stack.
this is
Char star.
like C++. The delegate shuffle thunk configure. I hate this thing. Go away.
Minimize.
All right. So I'll step into nowhere, and I'm in configure, app delegate, libv, run, and what's this? Say localhost 5000. It prints hello world. That worked.
Woo!
And if I look at the working set, it is 2 megs of working set for an ASP.NET application. I don't think I've ever seen that,
No.
ever.
So those are the type of benefits we're talking about. Incredibly fast startup time and very low working set. As in you start the app and it uses a very minimal amount of RAM to start with.
I can ask this at a later time if it's not a good question to ask now, but what is the post-mortem debugging experience going to be like for this? So today, if we get a memory dump from a customer, all the stuff like WinDebug and SOS, if it's running .NET native, I mean, what's the experience for like that? Is it LLDB or how would you debug a
That's a great question. I would hope the answer is it's as simple as debugging a managed application.
Is there anyone
today.
in here from
and
that?
I'm looking at Richard and I'm looking at the .NET
Anyone
people.
in here from that team that could say anything about that at all?
So
Or is it to be determined?
I assume it would work.
with .NET Native, it's a little like still growing, but like in debugging some of the native code we wrote for running the shared runtime host, they have you can use LLDB, which is the LLVM debugger, and they have a version of SOS, which is the WinDBG plugin that works on LLDB. They've been building these things, so the tools are being built.
Built for these platforms.
So
Yeah.
I think those tools will come.
So as part of the generation of the native code, the idea is that the PDB tools
Right.
Right.
So
Yes.
that was a comment from Peter, who's one of the managers on the .NET development team. He said, as part of generating the native code, we effectively generate PDBs for you. And so you still get a good debugging experience. I'm just paraphrasing here for everyone
Yeah,
else.
so this code reads PDBs for the actual assemblies that it compiled and generates line pragmas.
So
you
I
can
would, just to
point back.
frame this in terms of timelines, so people...
Oh, this is fuzzy.
Right, so
yeah.
if you go back 2 years ago, when we started talking about K and showing you, like Fowler came in after the 2 nights of not sleeping and showed you a demo of K, space something working, we're not even to that point yet in this, in some aspects. Other points where we're further on, but this is very, very early, especially in the context of ASP.NET. Okay, in the context of non-web console apps, I think we're further ahead with the vision a little bit close. But for ASP.NET, I think you want to think about this as a multi-year roadmap from today to where you would be able to compile a realistic ASP.NET 5 application, doing all the things that it does today, MVC, tag helpers, EF, all that type of stuff,
Razor.
to native. And I mean, let's think 2 to 5 years. Okay? It may be that in a year from now, there are bits we can share that will let you do a similar basic ASP.NET application down to native. But to do anything more complex, I think it's going to be a little bit longer. But that's still to be determined. But we wanted to show you now.
Another question.
Yeah.
what would exception stack trace look like?
So the question is, what would the exception stack trace look like if you were to throw an exception?
Magic.
Like that?
Oh, I don't think that works right now. I think it just like AVs and crashes.
Yeah.
It's pretty funny.
I
Actually.
think again that's another one that it will.
To show how
Work
early
better.
it is, I couldn't do string concat because certain overloads explode. So
But how about we answer this generically?
Yeah.
You can imagine that we're not going to give you this great new feature, which is compiled native, but have the cost be you throw away
Everything
all
you
the
learned.
productivity
Yeah.
of running a managed app after you compile. We're not going to accept that, right? Like, in order for us to bless this and make this a first-class feature for ASP.NET applications and obviously console apps as well, we need to ensure the full lifecycle of managing your app is good. Now, Peter has a comment.
So we use a lot of this technology already underneath UWP apps and videos. And what happens for stack traces is you end up getting a full stack trace that shows your managed part of the stack as well as the native part of the stack. And then in Visual Studio, there's collapsing features where you can say, I want to see in C#, but never show me that C++. So it lets you dive in if you really want to dive in, but you can just do your managed stack kind of the same way you want.
So for people who are watching online, basically we're already using large parts of this .NET Native experience in the UWP platform today. And when you get a stack trace in that world, you get a full stack, which includes your managed stack and your native stack. And then we use tooling features in VS to allow you to sort of, don't show me the native stuff, I only care about my managed stuff. Or you can look at the full stack if you like. Yeah? Cool. All right.
awesome. So let's show a few more things. So the tool is pluggable. As Andrew was saying that when you run .NET something, .NET foo,
Something.
it just runs .NET dash foo, even though
Oh,
this gives a weird.
There's a bug.
I found a
yeah.
bug on that actually. Because
It should have said, could not find command .NET dash
Yeah.
foo.
Where's the dash be?
Instead, it tried
It
to
says,
load a
it said
Windows
abort
DLL.
trap 6. That's what I saw.
Yeah, yeah.
That's fine
But
actually.
that's what
So-
that means.
Oh, okay, right.
But it means that the .NET compile, I can change compilers.
Yeah, do
So
the
one
dash
thing
V.
that we get for free is we get multiple compiler support for free. So VB, who uses VB in here?
Who's missing VB in ASP.NET 5? Come on, you can admit it. Wait, no one?
Oh,
So all of you people
how about F sharp?
get F sharp.
Oh,
There we go.
Got to pick the right compiler.
Yeah,
Yeah.
I
There
just
we
I
go.
just said
Sorry.
it just for fun.
COBOL.
So the way that works today is you call .NET compile and it calls .NET compile something. We have an extensibility point in the JSON file where we can say .NET compile, change the name of the compiler to run .NET compile dash this compiler. So I compiled a thing called .NET MCS, which is the mono compiler. So if I did .NET compile MCS, this is a command I have in my path that uses MCS to compile code.
And it's not part of the .NET tools
It's not.
we're building. It's
It's
just
a
something
thing
you
on
play
the path. So I selected the compiler for this one project and I made it use MCS. So if I compile this, it's actually a little faster. So poke at the Rosin team. It's a little faster than Rosin today.
It's a little faster right now.
Fix that. Okay. So because of that, VS Code has support for debugging on mono. What you get now is ASP.NET 5 plus mono plus debugging out of the box. So I can step on my Mac and see breakpoints and
Now, I guess the crux, the point to take away
Yeah.
from that demo, because it was somewhat random,
it was pretty good.
you know, it didn't really flow in from the native
I
or
know.
anything. The point here was that because of the nature of the .NET command line, the .NET CLI, this driver, and that it really isn't opinionated about the things underneath it. It just is a way to dispatch high-level .NET commands into lower-level commands that are very simple and composable.
You can compose
David
any
created
kind
a new command, .NET-compile-MSC. He created that compiler, and then very simply was able to run .NET space compile, and it would compile
Change
using that thing.
the compiler.
And the benefit of that in this case was that there's already an experience on a different tool, in this case VS Code, that
For
can
debugging.
work with mono-compiled stuff and give you debugging.
Right.
So F Sharp is a great example. If there was already a tool set for F Sharp and you wanted to use the great F Sharp analyzer thingy that only works on F Sharp stuff, then you plug in a command, you recompile your thing that way as one example, and now you've composed into the existing ecosystem. You could wrap that in a package, let people install it, and now they can run it using the same .NET command line experience, but call into your thing. Does that make sense?
So going back to native, does that work on all the platforms by generating C++?
So the question was, with native, does that work on all the platforms by generating C++ and then compiling that C++ for that platform? So the answer is maybe. So Fowler alluded to it quickly, which was there are multiple ways we can get C# code to then end up being a native image. One of those ways is to compile from C# into IL, and then from IL into C++, and then C++ down to a native image. One of the other ways is we can take that to IL and then use Ryujit to take the IL and turn it into native code and then run that through a bunch more stuff to make it a native image. So the answer is
It's like LAC.
yeah, and then there's things like Lilac. Yeah, Lilac, which is
LLVM
what's it stand for? LLVM-based
LLVM-based
compilation
plugin, yeah.
tools for .NET Native. So
In UWP, we use the Windows UTC compiler straight from IL.
Phoenix.
right, so there are many. This is the world of native. In the world of native, there are like 1,700 different ways you can take your code and turn it into the actual native image, and it differs by platform. Some are cross-plat, some aren't. Like this is kind of the world of doing native development. But when it comes to .NET Native, the intent is that I just write C#, and I compile the native, and I get out a thing the other end that runs on the platform I asked it to run on. And beyond that, this is apps, but we're also talking about experiences for libraries as well. Like, what does it mean to take a .NET class library and compile that to native so I can call it from another native system that has nothing to do with .NET? That's a pretty interesting idea as well. So we're looking at all these things. Any questions?
Brain melting.
Yes, Richard.
Do the Docker demo?
I can't.
Do you have Docker demo?
Peter?
We're not doing the Docker demo.
So the Docker
And it's just
demo is we
running
can run this
inside.
thing in Docker.
Sorry, bro.
Yeah, it's just Docker.
Which of course you can do with an IL-based or a DNU or DNX-based app as well. But Docker is a first-class the scenario that we're targeting with this .NET CLI experience. And so we have functioning demos of a base Docker image that has this .NET, .NET SDK on it. And then your app is a Docker image built on top of that, so it only has a very small amount of stuff in it.
Once you guys get access to the repo, you'll see that our tests are actually running inside of Docker images. So we have very consistent validation.
Will WinForms be able to run as native as well?
So the question was, will WinForms be able to run as native? Don't think we have any plans.
So right now, .NET Native is targeting .NET Core.
Right.
And right now, the current plan is WinForms.
So the answer for those on the stream was, currently the .NET Native experience is part of the .NET Core umbrella of technology, I guess you would say. So where does .NET Native fit into things? It's part of .NET Core. So if you target .NET Core, you can compile to .NET Native. UWP targets .NET Core. ASP.NET 5 can run on .NET Core. It also runs on desktop, .NET Framework. But WinForms is exclusively a .NET Framework technology. It's not part of the .NET Core world. Hence, it will not be able to support .NET Native.
It's not because we don't care. It's the fact that when you're doing native, there are a bunch of different considerations that are required to make it actually work. So like things like refcommit doesn't work right now because you can't generate code on the fly, and that is baked into a bunch of assumptions in libraries in general. So there are a bunch of things that just don't work that used to work. So we're starting from a tiny surface area and trying to grow it out into more things to make it work more places. So WinForms is just too big right now. It's the full framework, so it's kind of hard to make it just work in that way.
Any other questions? No? All right. Thank you very much.
Yeah.